Hello guys, good evening. Today we're going to talk about the review problems that I sent you via the GC in preparation for the board work that we're going to have on Monday, our fourth board work. And the board work is all about the arithmetic and geometric sequence. However, as you may expect, that the board work is generally going to test your ability to not only perform the computation in sequences, but also understand the problem and use your ability to compute for sequences to solve the problem. A lot of what's required in order for you to solve the problem is in the comprehension. And hopefully this walkthrough is going to give you an idea on how to dissect a problem, how to divide the components of a problem, and then from the problem build your GRFSA and then come up with a strategy on how to solve it. Okay, so let's begin. I have a problem, and you may notice this is number 3 of the list that I gave you. So it reads, I'm going to read it. It says, a worker is stacking cans in a triangular display. You notice a triangular display is, it's, fewer cans on the top and the most cans are on the bottom in order for the triangle to be stable. Here's an example here. According to the problem, the top row has 3 cans. I'm going to place 3 cans here. And the bottom row has 41 cans. I can't place 41 cans on the screen. It's going to clutter the screen, so I'm placing a number here instead. And then it says each row below has 2 more cans than the row above it. So if the row below has 2 more cans, the next row would be 3 plus 2, that's 5. And then the next row would be 5 plus 2 is 7. I can go on until we go to 41, but I'm going to stop here. And what's required is we're going to look for how many rows, that's how many n are in the display. In the equation that we're going to use, and in the equation that we're using in the class, we're going to compute for the n. Okay? So let's analyze it a bit. If you notice, in the problem it says each row below has 2 more cans. This is already your common difference. You don't have to solve it. But in case you missed it, it's, in case you're having difficulty finding or understanding the problem and then finding the, common difference or other variables you need in the problem, then it is always a good measure to build your sequence, the first few terms of the sequence. In this case, let's put a number here. That's 3, 5, 7. And even if you missed the 2 more cans than the row above it, or even if you didn't realize that that's the common difference, if we're going to look closely on your sequence, the difference between 5 and 3 is 2. 7 and 5 is 2. So you'd know that your common difference is 2. I think we can go on. Your first row is 3. That's obviously your A sub 1. Your last row is 41. That's obviously your A sub n. Why A sub n? Because you don't know how many rows there are. But it's obviously the last, so that's A sub n. N being the number of rows and corresponding to the number of the last row. Let's populate our given. Our A sub 1 is 3. Our A sub n is 41, the last row. Our common difference is 2. What's required is, in our class, what we do is we put the letter of what's required, equals, and then a question mark. The correct, some other people use, I think that the term is GUFSA, that's given unknown, formula, solution, and answer. But in our class, we use GRFSA. It's a modified version where instead of an unknown, it's a required. It's something we need to spit out. I think that's basically the same, but I don't know. I mean, it works for me and for my class, so that's what I'm doing. And the formula, obviously, since we're given with an A sub n and A sub 1 and d, is we're going to look for A sub n is equal to A sub 1 plus open parenthesis n minus 1 times d. where a sub n, we're already given, is the last row, a sub 1 is the first row, n is the variable that we're looking for, and we don't have a value for that, so we're not going to substitute anything on that. And then d is a common difference, we already have that. If we're going to solve that, if we're going to solve the problem using the formula, all we need to do is to substitute what we know to the formula. And it gives us a sub n becomes 41 instead of a sub n is equal to 3 plus n minus 1 times 2. And then we're going to perform some algebraic, magic in order for... The goal here is to isolate the n on the right side. And we can only do that if we're going to eliminate all of the numbers that comes with it, But in an equation, we don't just simply remove them. We do something. And what we do in the right side, we also do on the left side. That's an equation, And whatever we do on one side, we do on the other. And hopefully by doing that, we remove the numbers that goes with the n one by one. And by doing that, we can isolate the n. The easiest way here that I see is the 3. And the only way for us to remove the 3 is to subtract 3 from the left side and 3 from the right side. And if we do that, that becomes 41 minus 3 is equal to 3 minus 3. That becomes 0 then, plus n minus 1 times 2. If we're going to rewrite to make it cleaner, that becomes 38 is equal to n minus 1 times 2. The next number we can remove is the 2. And we can only remove the 2 if we divide both sides by 2. So 38 divided by 2 on the left side, and on the right side, that's n minus 1 times 2 divided by 2. The 2 on the numerator and the 2 on the denominator cancels out. So we're given with 19 is equal to n minus 1. And it's very simple. In order for us to remove the minus 2 on the right side, we just simply add 1 on both sides, giving us 19 plus 1 is equal to 9 minus 1 plus 1. 19 plus 1 is equal to n minus 1 plus 1, And then resolving that, we get 20 is equal to n. And that's it. That's the answer we're looking for. N is equal to 20. That means there are 20 rows in that stack. Hopefully you learned something here. If you have questions, you can ask. You can always ask in our GC. In the meantime, that's it. Thank you for watching.